Let's imagine that Earth faces a crisis. Because of water scarcity and all these pollutions, Earth becomes uninhabitable. And let's assume that we found another planet which has all the resources for humans just like Earth in our nearest star system, the Alpha Centauri, which is 4.37 light years from the Sun. Now, what do? Can we make our way to the planet and inhabit it? One of the theoretical predictions for such interstellar travels is a black hole drive or a Schwarzschild Kugelblitz Drive. Yeah, these do sound loud. It's a starship powered by a black hole. We all have a general idea of what black holes are, but how are they formed? Let's get into it. Stars are held in perfect balance by two forces, the gravity and the radiation from the star. The inward pressure of gravity tries to collapse the star, but the outward pressure of radiation, which is due to the fusion of hydrogen atoms to helium at the core, balances it. For stars way massive than the Sun, this fusion continues all the way up till it starts forming iron. Unlike other elements, we can't get any energy by fusing two iron atoms. So the radiation stops and gravity loses here, and so the star implodes. The outer parts of the stars are expelled into space so violently, and the core collapses under its own weight. If the core remains massive enough, the gravity collapses it into a black hole. But what is the Schwarzschild black hole? Schwarzschild or static black holes are those black holes that has no electric charge or angular momentum. Now, can we produce a black hole artificially? Physicists believe that black holes can be formed just with light, and this is called a Kugelblitz, German for ball lightning. Yeah, it gets interesting. General relativity predicts that when a lot of mass is packed into a very little space, this sufficiently compact mass can deform space-time to form a black hole. Example, in order to convert the Earth into a black hole, we have to compress its entire mass into a sphere which has a diameter of 16 mm. It's unimaginable, right? Okay, now let's take the most famous equation of physics, E is equal to mc squared. It says that energy in a matter is equal to the product of its mass and the speed of light squared. Now, let's look at it this way. M is equal to E by c squared. According to this, an energy E can manifest itself as a mass which is equal to the energy divided by the speed of light squared. That's an incredibly small mass. So, mass may be a property that all energies exhibit. To get a detailed view on this one, check out this video from PBS Spacetime. It's really useful. We have to supply really a lot of energy in the form of light for it to act like tiny bits of matter. So a sufficient energy of light focused in a small region can form a black hole, the Kugelblitz. But the amount of light required to create a Kugelblitz is very high. To create a Kugelblitz with a mass of 50 million kilograms, you will need to squeeze all of the sunlight that hit Earth last year into a volume 8,000 times smaller than a proton. It's unimaginable. So here's an important question. How do we use the black hole to power the engine of our spaceship? The groundbreaking work of Stephen Hawking made us realize that the quantum mechanical effects near a black hole's event horizon would give rise to an emission of radiation called Hawking radiation. A black hole emits a crazy amount of Hawking radiation. The smaller the black hole, the greater is the radiation, lesser is its mass, and shorter is its lifetime, until it completely evaporates. This radiation can drive our starship. A black hole which has a mass of about 2 Empire State Buildings will roughly be the size of a single proton, and it will radiate about 160 petawatts and would evaporate around 3.5 years. But how do we capture that energy? Here, a Dyson cap, which is a small section of a Dyson shell, can be positioned such that it would absorb the radiated energy from this Schwarzschild Kugelblitz and feed it to the engine to provide a forward thrust. Now, what's a Dyson shell? A Dyson shell is a variant of the Dyson sphere, which is a hypothetical megastructure that completely encompasses a star and captures most or all of its power. The thickness and diameter of the Dyson cap should be perfectly optimized to provide a greater acceleration. Large diameter and large thickness would increase the amount of absorption of radiation. But if the amount of material used is increased, the Dyson cap becomes too heavy and it reduces our acceleration. So now let's assume that we can cover the Kugelblitz with a tiny Dyson shell so that we can capture the total energy from it. This amount of power can accelerate us to 0.1 c in 20 days and probably to significant fractions of the speed of light in the lifetime of a Kugelblitz. There are also some challenges for building such a starship. Construct a Dyson shell or cap, an exceptionally light and very absorptive material would be necessary because a 20-mile radius 0.4-inch thick titanium Dyson shell will have a mass of more than 1200 Empire State Buildings. And in order to make a Kugelblitz, you must focus a lot of light in a tiny space, and so it becomes really hard since heat is also a form of energy. It will be so hot that even surpasses the Planck temperature. Temperature of the universe 5.4 into 10 to the power minus 44 seconds after the Big Bang. And at that unbelievably high temperature, you may not know what will happen. So I think it is better for us to reduce the pollution rates and conserve natural resources and continue our life peacefully in our home planet until anything very critical happens, such that we have to find another planet for survival. So what do you think? Will humanity be able to colonize other planets? Comment below. Subscribe to our channel for watching many science and technology related videos like this. Thank you.